Welcome to The Explainer. Today we're jumping right into a really fascinating guide called Sparking Motion, an introductory guide to robotic power. You know, even if you're already super well versed in robotics or basic engineering, you are going to love this. The way this guide uses these everyday biological analogies to teach fundamental mechanical concepts it's incredibly insightful. It breaks down the absolute essentials of energy in a way that just instantly clicks for anyone. So let's get into it.
Okay, the guide hooks us right out of the gate with a really clever premise. It asks, do robots actually need to eat like we do? It's taking this strictly biological process, acquiring calories for fuel, and applying it directly to a machine. And by framing it this way, it completely grounds these abstract, kind of dry electrical concepts in an intuitive reality we all get. Because, just like us, robots absolutely require a consumable source of power just to survive, function, and do their jobs.
Which brings us to our first core concept, Section 1, the robot lunchbox.
So the text relies on this incredibly relatable nutritional metaphor. It explains how a battery is, well, it's simply a lunchbox holding stored energy. And what makes this analogy so effective is that it deliberately skips over the heavy physics right at the start. We're not talking about voltage or current or resistance yet. Instead, it makes sure the foundational logic is locked in first. Stored fuel equals potential movement. Basically, before a machine can take a step or spin a wheel, it literally has to open that lunchbox and consume its stored fuel.
Now that our robot has its snack, let's look at Section 2, Mapping the Power Path.
The guide traces the electricity's journey through the system in 3 super clear steps. Step 1 is the battery. That's our raw power source. But that energy doesn't just flow randomly all over the place. It travels to Step 2, the microcontroller, which actually processes and directs the current. And finally, that directed power flows down to Step 3, the motors. It's a brilliant way to break down a complex electrical circuit into this highly logical sequence. The energy is drawn, it's processed, and then boom, it's executed as a mechanical action.
And here is where the source material gets really clever. It maps the robot's anatomy directly onto human anatomy to completely demystify the mechanics. Think about it. Just as your human brain commands your muscles to physically move, the robot's microcontroller acts as its brain, directing the energy it got from the battery straight into the mechanical motors. Grounding complex engineering in a basic biology lesson we all intuitively understand is just a fantastic way to make the inner workings of a machine instantly relatable.
All right, moving on to a more hands-on approach with Section 3, the battery safari.
At this point, the educational guide encourages you to take these abstract concepts off the page and out into the physical world. It prompts this practical search, asking you to literally open up household items and identify the various battery types powering your own home. By actively going out and uncovering these hidden power sources, this whole abstract idea of robotic energy becomes incredibly tangible. Actually getting up and taking that learning into your physical environment is a proven way to really lock in what you've learned.
But before we get too carried away exploring, we have to cover Section 4, Safety First, Essential Protocols. Now, while that safari activity is super engaging, the guide wisely shifts to a strictly serious tone here regarding mandatory safety. It heavily emphasizes that you must never short the battery terminals. If you connect the positive and negative ends directly without a proper path, you're bypassing that entire intended power flow we just talked about, and that creates a genuine, serious hazard. So exploring is highly encouraged, but respecting the basic physics of stored electricity, that is an absolute requirement.
By laying out and following these strict protocols, the guide achieves its ultimate goal, allowing us to safely understand the essential connection between stored energy and mechanical movement. Once you truly grasp how the lunchbox feeds the brain, and exactly how that brain commands the muscles without creating a hazard, well, you possess the fundamental building blocks behind all functional robotics.
So as we wrap up today's explainer, I want you to consider your own environment for a second. Seriously, take a look around and ask yourself, how many hidden robot snacks are silently powering the space you are sitting in right now? From the devices in your hands to the appliances on your walls, that power path is functioning silently all around you. Keep observing those fascinating systems moving our world. Thanks so much for joining me.